Okay, guys, so what I'm going to do here is kind of maybe clear out some confusion you may have about chemical bonds. As you guys know, chemical bonds definitely only occurs with the electrons, the subatomic particle electrons that's actually outside of the nucleus, okay? So, the chemical formula, anytime we have a formula, okay, up here, whether it be an ionic bond such as L1F, or a covalent bond such as H2O, okay, H2O, or if it is a metallic bond, for example, let's say lithium and beryllium. Okay. Now, remember I said when we talk about chemical formulas, the element symbol, remember an element symbol, the first letter must always be capitalized and the second one must be lowercase. Okay. So in this scenario, L1 is one element, one atom of an element, and then F, sometimes it can just be by itself, and then it would just be capitalized. Okay. Now, there are times that you will have, well, a lot of times, you will have what is known as subscripts, and these are the numbers that are written to the right of the chemical symbol slightly below it. So right here, like H2O, CO2, H2O, NH3, okay? And that tells you, for example, the ratio, all right? So how many carbons do we have? One. How many oxygens do we have? Two, all right? How many hydrogens do we have here? Sorry, I wrote the wrong thing there. Two, how many oxygens? 2 to 1. So what this is saying, I have one carbon atom to two oxygens in this chemical formula. H2O, I have a 2 to 1 ratio in this chemical formula. And then NH3, we have a 1 to 3 ratio. We have 1 nitrogen to 3 hydrogens there, okay? So, really quick, in the notes section of your notebook, your flip section, tell me what kind of bonds is this? CO2, H2O, NH3. Write it now. Okay, so an ion is a charged atom, positive or negative, okay? So, if you look here, I've been talking about ionic bonds, okay? So an ionic bond, the most important thing that you need to understand is that it is a bond between a metal, which I said that's called the dude, right? And then the nonmetal, that's called the chick. Okay? Now, this only occurs in an ionic bond. A dude is a metal, a chick is a nonmetal. So for example, if you look at sodium and chlorine, okay? So what I want you to do is that right now, I want you to, in your flip section of your notebook, this is the second part, checkpoint I want you to do. First of all, I want you to write I want you to write the bonds there. Okay, so what I want you to do, I want you to go ahead and do that right now. NaCl MgO. What I want you to do is I want you to write it in the flip section of your notebook. Go ahead and pause this video. Write it in your flip section of your notebook. But I want you to use the Lewis dot structure. I want you to show me with dots where the electrons are, who's taking one, who's giving it away. Then tell me what they are named after they're pronounced man and wife. Do that now. Okay, so as I asked you, let's go ahead and do the first one together. So you need to find sodium, Na, on the periodic table, which is in group 1. Okay, so in group 1, I wanted you to write Na in one dot. Okay, because remember it's in group 1, so that means it has one electron in the outer shell. And then on Cl, I wanted you to go ahead on that one. How many do you have in the outer shell? Very good, 7. 1, 2, 3, 4, 5, 6, 7. Now, what I want you to do at this time is I want you to look and say, okay, what do we need to do here to make them full, fat, and happy? Okay, so in a marriage, this is a very unhealthy relationship. This is an ionic relationship where the dude's always giving up to the chick. All right, so here in this scenario, what you're going to do is see how the dude gives up the electron. All right, once he has, then now he no longer has an electron in the outer shell, so he drops down to the next shell. Okay, so now since he lost one negative electron, now he becomes positive by one because now he has one more proton than the electron when it was stable, because now it's unstable. Okay, very unstable, unhealthy relationship. Now over here, since the chick gained it, now the chick becomes a -1 because she just gained an electron. Once they've been married, now it's called Mr. and Mrs. Sodium Chloride. Okay, so remember, it always changes that last part there. Okay, all right. Now magnesium. If you look here, you can see magnesium. Okay, is the dude. All right, and he has 2 in the outer shell because he's in group 2. Oxygen is in group 6. Okay, so oxygen is in group 6. So 1, 2, 3, 4, 5, 6. All right, so magnesium, if magnesium loses that 2 in the outer shell, it can lose that outer shell, drop down to the lower level shell and become full, fat, and happy. And oxygen can gain the 2 and be full, fat, and happy, because remember, that's the ultimate goal for all atoms. Okay, so in this scenario, what's going to happen is the dude's going to go ahead and give up those 2. All right, so since we lost 2 negatives, now we have 2 positives. All right, and then if you look at the girl, she just gained 2 negative electrons, and then what you will have in this scenario is what is called magnesium oxide. Okay, now what I wanted you to see here is the fact that these are called ions. Okay, ionic bond, get it? So here, for example, is a +1, so he is a sodium is a +1 ion. Over here, chlorine is a -1 ion. Okay, over here, magnesium is a +2 positive ion, and over here, oxygen is a -2 ion. Okay, so positive ion, negative ion. This is an ionic bond. Okay, so let's go ahead and move on to naming ionic bonds. So we have this here. We actually been talking about that after they've been married. All right, so right now I want you to go ahead and I want you to draw these out, meaning not just with dots. I want you to draw out the shells for me, and I want you to show me what happens after they come together. I want you to show me the charges and what it's named. I do want you to draw all the shells and all the electrons there. So go ahead and do that in your flip section now. Okay, the next one is covalent bonding. Okay, this is bonding of an atom in which the electrons are shared. Okay, nobody's taking, nobody's giving. Everybody's about, I want all my friends to be full, fat, and happy. I want all my friends to get presents for Christmas. Okay, and this occurs with 2 nonmetals. Okay, with 2 nonmetals. All right, and it's called a molecule. When you bond 2 nonmetals together, it's called a molecule. All right, so for example, H and H. So the other thing I wanted to point out, these are terrible conductors. Poor conductors, great insulators. Great. All right, so what we're going to do here, now when we talk about a covalent bond, it means that the electrons are shared. Okay, there's no taking, there's no giving. They're just sharing because they're besties and they want everybody to be happy. So for example, let's do carbon dioxide. All right, so carbon dioxide, I always said take the one that you had the least of in the center, which is carbon, and then you put the one you have the most of on the outside. Okay, so you got to think, how would they bond in order for them to be full, fat, and happy? And you know the magic number's 8 once you get past that first shell. All right, so oxygen is in group 6, so it has 6 electrons. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. All right. Now, carbon, if you look at carbon, it's in group 4 and it only has 4. So I'm looking at this and I'm like, okay, well, oxygen has 6, so it needs +2 to share to be full, fat, and happy. And carbon needs +4. So what can we do to get them full, fat, and happy? Oh, okay, so they can share these two, share these two. All right. So what happens is at times, both of these will be over here. At times, both of these will be over here. Okay, will be over here and over here. All right. Now, vice versa too. Okay. It can go the other way as well. Okay. So this is actually each line here. All right. So let me show you that. So each line represents a bond of two electrons. So we count them as 2. So 2, 4, 5, 6, 7. I'm sorry. 2, 4, 5, 6, 7, 8. Do we have 8 there? Boom. Good job. Over here, 2, 4, 5, 6, 7, 8. Got 8 there? Good job. 2, 4, 6, 8. Okay, so now everybody is full, fat, and happy. Covalent bonds, they all want to be happy. They all want to share. They care. So they're going to bond in a way that they can share all their electrons, put all their resources together. So at times, they can be full, fat, and happy. Okay, so let's go ahead and look at the next one here, metallic bond. Okay, now when I talked about compounds, okay, compounds can happen between metals, a metal and a metal, and it can also happen between a metal and a non-metal. All right, now a compound, okay, is actually, like I said, it's just those two. It's a metal plus a metal, or a metal plus a non-metal. All right, and all it means is that the you can have the same elements, okay? For example, you can have the same elements, but as long as you have a different amount of ratios of them, like 2, 3, 4, 5, then that's what we call a compound. All right. And then on the metallic part here, that I want to share with is that they are electrons. They form metallic bonds, and we don't really draw those out. They just basically, it's called the 60s, man. It's where everybody's free and loose. We share, we care. All right. And this is once again a sharing, but this is called like a sea of electrons. And what they do is they're loose bonds, and they have the ability to move freely without breaking the bond. Okay. And they share their electrons equally in all the same directions. Okay? And that means you can stretch them without breaking. They're very malleable and they can be shaped, and they're excellent conductors. Okay? All right, so the last thing I want to leave you with here is going back to the ionic bond, which I feel like I want to make sure that you guys understand this. Now, ionic bond, because we are giving electrons, we are creating charges, okay? So that allows you to conduct electricity when you have charges to occur within a solution. So, for example, here we're looking at sodium chloride, okay? And sodium chloride, because we have a charge, salt water, it dissolves very easily because it's not as tight a bond as a covalent bond. Covalent bond, like sugar water, okay, is real tight. And sugar water does not dissolve very readily in water, okay, because the bonds are so tight, it takes more than that to break them up and to dissolve, okay? But if you go back here and you look at your ionic bonds, which you do have charges, okay, it does dissolve in water because the bonds is not as tight, all right, and it is giving out a charge. I hope this helps you guys out. Go ahead and complete the assignments that I asked of you, and I will check your answers here in just a little bit. Peace out.